Hello everyone, this is Salman sir here with the second video of chemical kinetics. In this video, we are going to study the law of mass action and order of reaction. Now, according to the law of mass action, at constant temperature, the rate of a chemical reaction is directly proportional to the product of active mass of reacting species with each active mass term raised to the power equal to the stoichiometric coefficient of that species in the chemical reaction. Now, what is the law of mass action? We are taking the one example, A molecule of A combined with B molecule of B form product or products. Now, here, what will be the rate of reaction? The rate of reaction will be directly proportional to the product of active mass of reactant with the power will be raised equal to the stoichiometric coefficient. So we are having stoichiometric coefficient for A is small a, power will be small a to the power a, and stoichiometric coefficient is B for capital B reactant, then it will be B raised to the power B. Now that will be the law of mass action that can be calculated. Here we have used the term active mass. Active mass may be the concentration. If we are taking in mole per liter, we are talking about liquid solutions. And if we are talking about the gases, the active mass will be the partial pressure. The active mass may be concentration, the unit will be mole per liter, and active mass will be the partial pressure, unit will be atm, bar, millimeter of mercury, when the reactants are in gaseous state. But the law of mass action, the prediction given by law of mass action may or may not agree with the experimental fact. So most of the time we are going to get the correct value calculated with the help of law of mass action. But many time the law of mass action is not giving the value which favor the experimental fact. Now, the information derived on the basis of the experimental facts is generally expressed in the form of rate law or rate equations. So here the difference between rate law or rate equation and the law of mass action. Law of mass action gives theoretical value and rate law or rate equation is going to give the experimental fact. Now for the same reaction, here the rate of a reaction is directly proportional to the concentration of A to the power x. We have not taken the power A to the power A here. We have taken A to the power x. And here we have not taken B to the power B here. We have taken B to the power y. Because experimental fact will maybe differ from the theoretical fact. So A plus B, small a plus small b will may or may not equal to the x plus y, because x plus y are derived from the experimental fact. Now how we are going to derive, how we are going to do the experiment, you can see here in order of reaction. I am going to explain the order of reaction in continuation. The power to which the concentration term of a particular reactant in the rate law is raised is called the order of reaction with respect to that reactant. Now, if we are doing some experiment, we have taken one example of de-esterification. Ethyl ethanoate is treated with water, form ethanoic acid and ethanol. And we are going to do the experiment. So now see here, we are keeping the concentration of water is constant and we are doubling the concentration of ethyl ethanoate. If the concentration of ethyl ethanoate is doubled, we found that the rate of reaction also become double. It means the power will be 1. If the concentration of ethyl ethanoate become half, the rate of reaction also become half. That shows that the power is 1. So we can say that with respect to ethyl ethanoate, the reaction is first order. But if we are keeping the concentration of ethyl ethanoate is constant, fixed, and doubling the concentration of water, we find that it don't affect the speed of a chemical reaction. It means if we are doubling, just making half or 4 times, 10 times the concentration of water, it is not going to affect the speed of a chemical reaction. That means the concentration of water will be raised by power 0 because it is not affecting the rate of reaction. So here we can say that with respect to water, the rate of the reaction is 0, zeroth order. But if we are talking about the overall order of this reaction, the overall order of this reaction will be 1 plus 0. So this is a rate law equation because this equation is created on the basis of the experimental fact. Then the sum of the power of the active mass of reactant will be equal to the overall order of reaction. So 1 plus 0, it will be the first order reaction. But if we can see that according to the law of mass action, here two molecules are participating in the reaction, one molecule of water and one molecule of ethyl ethanoate. So the number of molecules are 2, so we can say that it is a bimolecular. Molecularity is 2 is bimolecular. So it's bimolecular, but order of reaction is first. We can say that it is first order bimolecular reaction, that type of reaction in which the reactions molecularity and the order of reaction is not same, law of mass action and rate law is not same. In that case we can say pseudo molecular reaction, but this is first order reaction, so we can say that it is a pseudo molecular first order reaction. Please take the screenshot and note down.